Hello chemists and welcome to Bales Chemistry. This is the start of AQA Specification 1.9 rate equations, and in this episode we are going to look at initial rate. Questions on this topic will appear on paper 2 of your final exams. Before we can do any calculations of rate, we must first take some measurements. We either want to measure the change in reactants or the change in products. Now this could be measuring the amount of gas produced as a product, the pH change of the reaction mixture, a colour change using a colorimeter, or a mass change using a normal lab balance. Now, calculating the pH or the colour change usually requires stopping or pausing the reaction so we can take our measurements. This process is called quenching, and it works by removing one of the reactants or the catalyst enabling the reaction, usually by neutralising it. For example, a sulfuric acid catalyst could be neutralised by a sodium carbonate solution. Once we've collected our data from our reaction, we'll want to plot the data on a graph. To do this, we plot the concentration on the y-axis and time on the x-axis. In some reactions, rate is constant and it will give a straight line. However, it's much more common to have a curved line showing a steadily decreasing rate of reaction. There are some reactions where a rate will actually increase as the reaction progresses. These reactions rely on a catalyst generated by the reaction, and we'll look at this in our transition metal topic. Once we have our plot, we can work out rate. Now rate equals the gradient of the line, as this shows the change of reactants or products divided by time. So the rate at time of 1 minute is calculated by drawing a tangent at 1 minute and then working out the gradient. Now the rate will decrease as the reaction progresses, so the rate at 1 minute will be greater than the rate at the second minute. This range of data makes a comparison to different reaction concentrations more complicated. To make that comparison easier, we'll look at the initial rate of the reaction. This is the rate at the very start of the reaction when time equals 0. This allows chemists to make a quick comparison between running the reactions with different concentrations of reactants. Chemists can then observe the impact of changing these reactants on rate. So to do the initial rate method in the lab, we set up the reaction, we're going to collect the data for a short amount of time. We'll plot the graph and calculate the rate at the beginning of the reaction. We'll then change the concentration of one of the reactants, and then we'll repeat the process until we've changed each reactant once. In this area of the specification, we're particularly focused on comparing how changing these reaction concentrations changes the rate. Having collected reaction data for a range of different concentrations, making sure to only change one concentration at a time, we can plot them as 3 separate graphs. Or we can plot all 3 experiments on one graph. Once we've done this, the data can be placed onto a table. Now to calculate initial rate, we're only interested in the very first part of the experiment, so I've zoomed right in on all the graphs to focus on this point. It is then possible to calculate the gradient and then the rate, and then we can add this to our table of data. Now that we've collected all the data, we can use it to calculate the rate equation and the orders of reaction, and I'm going to explore this in the next episodes. So in summary of the important points from this episode, first off, quenching a reaction stops the reaction. Secondly, the y-axis is where we plot the change of the reactants or the products, and the x-axis is where we plot the time. Rate equals gradient, and this can be worked out by using a tangent on a curved line. Initial rate can be used to compare the change in reactant concentrations. And finally, the initial rate takes the gradient at t equals 0. Thanks chemists for watching this episode of Bales Chemistry. Remember to like, subscribe and comment below.